Alright, so this is Thursday the 25th of August. This is period 6, Algebra 2, number 14. Okay, what does 14 say?
What is the slope of y-intercept of y equals negative 2x plus 4?
Y equals
negative 2x plus 4.
Does anyone know what form this fits here?
This one.
Good. Y equals mx plus b. And what is the name of this? Slope-intercept form. Slope, y-intercept, so slope-intercept. So it just wants the slope of the y-intercept, so slope would be -2, and the y-intercept would be 4. Okay. You should definitely know how to graph something like this. So, not too small. So it's pretty much similar to how you would do it on graph paper.
Well, there's no graph.
What's that?
There's no graph on here for that one.
Yeah, but we're going to go over how to graph it. Okay, so we'll keep it blue. So where would I start with this, graphing this? 4. On the y-axis, yeah, it's y-intercept. So the point should be 0, 4, 1, 2, 3, 4. All right, this should make sense because if I let x be 0, y would be 4. So, something to keep in mind, the basic fundamentals of this is that any point on your graph should satisfy your equation. Okay, so then how many points, what's the minimum number of points we need to define any specific line? 2. Okay. It's always going to be one more than the degree of your functions. This is a linear function that's of degree 1. You guys have studied degrees at all in Algebra 1? Degree 1, like, for example, if I put a 2 here, what kind of equation, what kind of function would that be? So it's no longer linear. What is it? Quadratic? You guys ever study quadratics at all?
Yeah.
Yeah? Okay. So how many points would we need? How many points, if we had this many number of points, would guarantee that, okay, there's only one graph for this specific quadratic? If I'm saying the rule is always one higher than the degree. How many points would you need, say, ignoring the vertex, say one of them's not the vertex, but how many points would you need in order to graph this guy? What's the minimum number? 3. You need one more than the degree. So this is of degree 2, so you need 3 points. So when we're dealing with just a linear, we just need 2 points. All right, so how do I come up with another point? What's that? Rise over run? What exactly would I do?
If you go down to the
down 2 into the right one, right? And, you know, you could do more just so that when you hand draw your line, you're very accurate. As accurate as you can be. And so there's an infinite number of points, but 4 is good. Technically you only need 2, and then just go ahead and graph. Any questions about this whatsoever, please ask.
So what they end.
But what did the question ask?
Yes. The y-intercept and the slope.
The y-intercept is slope. So what is the y-intercept? And what is the slope? -2 or -1, yeah. Okay. Any other questions? Okay. Any other problem you guys want to go over? Number 11. Okay, what does 11 say?
Write an algebraic expression for the phrase -2 times the quantity q minus 3.
All right. Did anyone else get that? Would someone feel like sharing what you maybe got? Yes?
I put 2x q minus 3 times q minus 3. That is not right.
Okay. So this is a problem where you grab one.
2 times q minus 3.
This is a problem where it could easily look like something else if you read it incorrectly, or depending on how you read it. So we have -2 times the quantity q minus 3, which is a different statement than -2 times q minus 3. So
You have to put q minus 3 in like quotation.
exactly, very good. Because it's -2 times the quantity q minus 3. Right? Which is completely different than if we just did this. Depending on how we read it. Yes? So, distributive property would be -2q plus 6. Is that right? If I were to distribute this -2,
Yeah.
okay. You guys gotta talk to me a little bit because I can't read your mind. So, which is not this. Okay. So for this problem, it's going to be this one here, this here, not this. Okay. Anyone have any questions about 11 or 10, which is similar to 11?
No, but I know how to do 15 and 16. The graph, that's just like the same thing when you get to the.
Yeah. Did you want to show up to class? You got it? Okay, so 15. Would anyone like to see how to do 15? Yes. Okay. So 15. Let's throw on some math. Back to, and in fact, actually, I like these. And I'll just change the color. So the blue is this guy. I'm going to make the red number 15. And it says y equals 3x minus 1. Alright, so it's the same principles here. What could we need to plot some point, right? What point can we plot? -1 is not a point. Points on this grid have 2 coordinates, an x and a y. So let's be very clear here, yes. Thank you, 0, -1 is a point. You need an x and a y coordinate for an ordered pair. Okay? So, now that we have a point, how do we do another point?
You have to do a 3 over 1.
Up 3 over 1, right? Because the slope is 3. 1, 2, 3 over 1. 1, 2, 3 over 1.
I thought since it was the negative one, you go the other way, or?
Well, the negative one's what you plot first, and then
Oh, yeah,
you
yeah.
go from there.
Yeah. Negative 1 is our y-intercept. 3 is our slope. And I don't want blue. What do you guys notice about these two graphs here, which is going to tie into what we'll be learning in the very near future? We'll learn right now.
They got dots on them, squares. Can I help you? Use that when I'm not smart.
Your interest rate.
All those
I
are so
did use
fun.
dots to represent points for each. That is correct. That is true.
It's a nice little graph.
Do
One is all matched.
if this were a system of equations, all right, we say we have a system. We say y equals negative 2x plus 4, and at the same time y equals 3x minus 1. Is there a solution to this system?
All you gotta do is put a 1 under the 3, right? That's the answer.
Put a 1 underneath the 3?
I'm saying that's how you know all your answers. All you gotta do is put the 1.
What 1? What are you talking about?
What?
No, let's not overthink this. This is really convenient, this graph. How do we know what the solution of a system is? If it's here graphically, what do you think the solution is? This blue line is the graph of this equation here. This red line is the graph of this equation here.
Oh, they intersect.
They do intersect. What do you think about the point of intersection? What do you think that is? Anyone?
I never was I got you.
Okay.
I use my brain.
You do not need any calculator for this.
That's how.
Oh, okay. Then please put your phone down.
I was
Yeah,
asking
yeah.
Google, so.
No, let's not do that. No one has any idea. Have you ever studied systems of equations?
What?
Raise your hand if you've never studied systems of
What was
equations.
the question?
I'm asking for the solution of the system. If we say the system is y equals negative 2x plus 4 and y equals 3x minus 1.
Would it be?
Oh, that's.
You're close, but it's not 1, 3. It's
There's a down line.
So y equals,
this graph is very convenient because it clearly shows us what the solution is. Yes.
Well, wouldn't it be the middle dot? The point of intersection?
Yes, it would be. Thank you. The point of intersection is the solution. You got it. So then what is this point?
It's y.
It's 2.
Oh, yeah, it's like 1, 2.
1, 2, yeah.
1, 2. That is the solution if this were a system.
You have to take this out. You have to take that.
What's that?
Nothing.
Yes, you have to take math. I think you do, yeah. Okay, so 1, 2, the intersection. This means, if you ever want to check yourself or you want to see if this is true algebraically, this better make not only this statement true, but also this statement true. Okay, so if I let x be 2, sorry, if I let x be 1, sorry, and let y be 2, does it make this statement true? Is 2 equal to negative 2 times 1 plus 4? Let me know if you want to see me actually plug it in on the, yeah, okay, so if I substitute, right, I'm gonna erase this here because you guys know it, that's just the general form, or just the form of the slope-intercept. If I substitute 2 in for y, and I substitute 1 in for x, does it make this equation true?
Yeah.
2 equals -2 plus 4, 2 equals 2. I'm definitely going to be testing you guys on this concept of understanding things not only algebraically, but understanding them graphically. This thing's like running away. There we go. Okay, so it should not only make that one true, but it should also make this one true. So let's see if it does. Does 2 equal 3 times 1 minus 1?
Yeah.
2, it makes a true statement. 2 equals 2, check. And over here, made a true statement here, 2 equals 2. It doesn't have to be the same exact statement. It could say 5 equals 5, and that would be a check, yes, made true statements, yes.
So what's the check if you have to, or is it, what do you check when you do that?
You could say yes to that. You could technically graph, because when you graph something by hand, what if I was a little bit off and it looked like the point was over here? Okay, that was a human error mistake. The algebra is usually going to be perfect, but when you end up graphing something by hand, especially if you're not using a straight edge, especially if it doesn't fall on one of these intersections of the grid. What if it's something fractional? Then you're like really second guessing yourself.
Yeah.
I don't want to focus too much on just solving a system graphically because of that issue, because of human error. Algebraically, you know 100%, you're 100% certain that the solution is 1, 2. Right? Especially when you start to get like graphing quadratics and they have curves, there's curves to the graphs. Okay, so we did problem 14 and 15, I kind of combined the two to touch on system because it just happened to work out nicely. Yes? No, not at all. By the way, when you guys do this, when you guys like ever do a quiz or a test, feel free to make your life easy and like keep the same axes for problems as long as your work is clear. Colored pencils may not be a bad idea because look how clear this is. Clearly, the red is this guy, the blue is this guy, right? So I don't mind you guys using the same axes for more than one problem, as long as you're clearing your work. Number 6, you said?
Yeah.
Okay. Number 6 says simplify. Would anyone like to show this for the class? Please feel free. Go ahead. Please. And explain it like, if you were to explain it to us like we don't know what's going on. Please. Thank you.
Oh.
Does it feel like there's some pressure anything in front of the class? You're fine. I think we all do that. Here you go.
Yeah. All right. So, because this is in parentheses, you do that first. Right? Let's see. Oh, true. Okay. Wait, is this x or is it multiple? Okay.
We're gonna go with both.
Can I just erase it? So And I was like confused with this bracket part.
So brackets are just like parentheses.
Alright,
They're like
so-
big parentheses. Good job. Fantastic. Would anyone like to demonstrate what it would be if you looked at that and you thought, okay, that was an X and not necessarily a multiplication symbol? Please. You can just hit the next page button, which is above the color palette. It's got a blue arrow on it. Thank you. Pick any color you like. Oh, I think it's standard black.
That's it. Can't do it anymore because it's not like terms.
Let's drop the bracket. Next line down. Very good. Anyone have any questions about this? Yes.
I thought you said something like that.
That, you mean the minus sign in front of the 5?
Yeah, because like, I thought there were like parentheses, so like I would multiply 30 by -5.
Oh, okay, good. That's a good question. Just so everyone gets the benefit of that question. Say you have.
I thought those were like absolute value, like, if they're in the brackets, they cannot be negative.
We'll cover that too.
Well, I think the brackets are there because there's already parentheses. You have to have brackets.
Yeah, it's very typical what you just said. If you have parentheses and you want to use like major parentheses, sometimes you'll see in textbooks they'll just write larger parentheses. Sometimes they'll do brackets. But brackets are usually the biggest guys of them all. So for example, if you had this 6 minus 3x plus 2y, I don't know, just some random expression. Working from the simplifying working from the inside out. Okay, take care of this first. And then when you have 3x plus 2y, it's just not necessary to have the brackets. The brackets are saying, what do brackets or parentheses tell us about? It says, hey, these guys are associated with each other. These guys are contained together. That's all it's really saying. But your question about, let's say you have, let's actually use the actual example, where we got to say 30x minus 5. So 30x minus 5, this is different than this. So these are not the same thing. This does not equal this. Yes?
Does that mean like you have to multiply?
Yeah, exactly. This implies multiplication. This implies, okay, I would end up with negative 150x. This here is just minus 5. What's that?
Like if it was -5 in the front of that, would you multiply both?
Yeah, good, no, good, that's good. So, say scum?
Oh yes, son.
Oh, okay. So negative 5, like this implies multiplication. Yeah, maybe that's also provides some clarity with that. This would definitely be negative 150x.
I have a question.
Yes.
What if, I mean, like the question with brackets in it, What if there's like more options that would be like double brackets? Or
Double brackets is uncommon, but if there were double brackets, think about working in terms of simplifying, working on all the way on the inside first, working your way out in terms of simplifying. Now there's a question about absolute value. Might as well just go ahead and touch on that. So absolute value bars, what they look like is this. This says the absolute value of x. Are you guys okay if I abbreviate absolute value?
Yeah.
You guys know what that means in your notes, okay? So that's what this says. If you have like that. Does anyone remember, can anyone tell me what absolute value means? Yes.
Well, like if it shows it's negative but it has the absolute value is positive.
Uh-huh.
Or if it's positive, it's still good.
Uh-huh. Good. So, definition of absolute value. Absolute value. The most simple definition that is 100% correct is absolute value is the distance from 0 on the number line.
Yeah, it's bigger.
Number line, I think, is 2 words. I don't care where it is. Not English class. Have you guys ever, raise your hand if you have studied complex numbers or imaginary numbers? Only 2 of you? Okay. Great. I won't go into that yet then. Any more questions on this?
You must like the number 0.
Do I like the number 0? I don't know if I like it. I like the number 13. Okay, so now we'll just look at some transformations. This is going to help you, yes. Number 9? Yeah, sure. So number 9 says, evaluate this. It says b minus 2a. Would anyone like to do number 9? Okay. Awesome. Where a equals -7, b equals 3, and c equals -7.
What if you put their 7s up?
What's that?
You put their 7s like with the line through it.
Maybe.
Right? Am I right?
Looks good to me. So I think what this problem kind of pushes us towards is just to be careful with minus and negatives. It's very easy to make a mistake on this if you're not careful.
9?
This is number 9. For those of you that maybe got some different, do you see where the simple mistake was made?
I did like the small mistake.
Okay.
Yeah, instead of subtracting 1 first, and then
So just be careful. Do exactly what it says. Any other problems you guys want to look at this here that you think We'll just make sure you got it right. Yes?
For 12 and 13, you would add
For 12 and 13. For 13, you would simply add the exponents and write as y to the 8th. But for 12, you would actually multiply the exponents, which would give you k to the 8th.
That's when you multiply.
And there's nothing wrong with going over this whole sheet, by the way. I didn't mean to imply that we should just only go over a few. We can go over this whole thing. So, now why is that for 12? Why do you think we,
because of the parentheses.
yeah, think about this. To raise something to the fourth power, that's to multiply by itself 4 times. So if you imagine, say, k squared times k squared times k squared times k squared, then you could add 2, 4, 6, 8, and you would have k to the 8. So in case you forget the rule, go back to just the basics, what it means to raise something to a nice whole number, what happens. Everyone's good on 1, 2, 3. Did everyone get 4? What did you guys get for number 4 for your answer?
I got the negative.
-3. You want anything different besides
I got
-3?
2. I don't know how.
You got 2?
Yeah.
You wanted to see it?
No, I just said I got 2. You agree?
You want to see it?
Yeah, sure.
Okay. So, distribution, yes? Yes. No, can you? I don't know, can you? I hope
Yes,
so.
yes, I can, I was asking for information. Because I don't know what the past is, what there is.
Okay. Can it wait, or do you have to really go? Okay. So, we distribute, because we're only in here for like 45 minutes. I think 12:29, so like not even 6 more minutes. We distribute, help me out guys, 3 times 2x, 6x is okay, then plus,
Yeah, 12.
Negative 1x.
Yeah.
minus 9, right? Okay. And then what do you want to do from here?
Add 9.
Add 9, plus 9, plus 9. Okay, if we do that, we would have 6x plus 21 equals negative x. Next thing?
Add x.
No,
Or
wait.
no.
Divide 6x.
So you subtract 6x and multiply, yeah.
The reason we add 9 to both sides,
So there's negative.
it makes it so there's no longer any constant terms over here. Just have the constant term now, 21 over here. So since we just have a constant term over here, why do we make it so we just have our variable terms over here? So minus 6x. And if you guys are comfortable enough doing this in one step, you can do that. That's fine. And then, so now what do we have here?
So negative equals 7. Negative 7.
I just, so 21, I know. 21 equals negative 7x. I know.
You divide by negative 7.
So x would equal
Negative 3.
negative 3. Do you see where your mistake was made?
Yeah.
Any questions? You good? All right, so everyone got 5, 7. What's that? You didn't get 7? What did you guys get for 7?
Negative 36.
Negative 36. Did you get anything? What's that? Negative 31? You didn't do it.
That was the number.
36, negative 36.
For what?
Or do we 7?
Would anyone like to do this? Or tell me what to do, yes?
It's, you multiply negative 9 and negative 8.
Okay.
72.
Uh-huh.
And then it's negative 2 in the bottom. And then you divide 72 by negative 8.
Right. Negative 36.
What did I do?
I want to show you guys something that's definitely very important. The more complicated it gets. So we started off with here. And I know it's like, okay, whatever. It's negative 36, who cares? But if this thing gets more and more complicated, don't forget the fundamental rules that you're allowed to do when you have a product and just a number by itself or another product. You're allowed to simplify individual factors. Remember this rule, guys? If we divide by, let's say, the greatest common factor of negative 8 and negative 2, well, let's say it's negative 2. What is negative 8 divided by negative 2? Positive 4. What's negative 2 divided by negative 2? Positive 1. So now you have something that's as simple as, I don't need to put parentheses, I just did though. Negative 9 times 4, negative 36 over 1. I know this one's very basic, don't have to necessarily do this, but I'm just telling you, it's going to make your life easier when these things get more complicated. Don't forget what you're allowed to do. Any other questions? No? All right, we're going to end with just a simple thing here. Which of these has a steeper slope? This one does. Even though the slope is negative, the absolute value of it is greater than the absolute value of this one's slope. Is this one line leaning forward or leaning backward? Leaning forward without even hesitation because of the positive slope. Is this line leaning forward or leaning backward? It's leaning backwards because it has a negative slope. And this will help you when you do the ACT or the SAT, and you have one of those problems, and it gives you, let's say, a linear equation. You can immediately eliminate two of the choices when two of them are leaning forward and the other two are leaning backwards. Well, it's a positive slope, so I can immediately eliminate the ones that are leaning backwards. Save you some time. Yes? You guys can hold on to that. I really remember tomorrow though, your syllabus sign off is due. So if you have that, feel free to turn it in on the back table. If you already give it to me, then you're good. You all have a good rest of your day.